Hey everyone, I'd like to spend a little time showing the demo that I created for my Intro to Multicast Breakout. It was supposed to be released after Cisco Live US, but we had some other priorities get in the way at dCloud and never got around to publishing this, and so my apologies to anyone at CLUS who was looking for this demo after my Multicast Breakout. I'm getting it ready now for CLEU in Barcelona, but I figured I'd go ahead and show it off, show everyone how to use it and what it looks like. I'm already logged in to dCloud here, so I'm going to go over to my hub and just click on that. It'll give me a session list. You can see I've only got one session running, my Intro to Multicast demo. So from here, we'll go over to the View button, click on that, and it'll show us the demo topology. Demo topology is pretty simple. Just a workstation, a viral server, and an automation box. Let's click on the workstation, and you can see here the credentials. We're not going to need them. Go ahead and click on Remote Desktop, and that will load a web-based version of Remote Desktop to log into the admin workstation. The first thing you'll notice when logging in for the first time is the scheduled job, which loads all of the programs you'll need to interact with the Multicast demo. Specifically, it's running a Flask app, which provides a web interface to load the topology, and PuTTY Connection Manager, which is preloaded with all the devices you'll use as part of the demo. Once PuTTY Connection Manager loads, it'll give you a list of the devices, and then right after that, it should load the web application for our Breakout topology solutions. So you can see we have a Sandbox topology, source-specific multicast topology, bootstrap router topology, AutoRP topology, and an Anycast with MSTP topology. These are the topologies that are covered in the Breakout, but for the purposes of our demo today, we'll just go ahead and do the bootstrap router topology. Once you click on it, it's going to take a few minutes to load. You'll know that it's working because you'll see it'll start turning the wheel there, and you'll see that it's trying to load the page. What it's actually doing on the back end is starting the automation, which is going to load the topology into Viral and spin up all of the devices. This takes a couple minutes, so we'll just speed this part up. After a couple minutes, the website should load and show the topology that's built in Viral. You can use this as a reference point moving forward, and it should match the Multicast Breakout demo topology as well that we cover in the Breakout. So now we can go to PuTTY Connection Manager and interact with the actual devices and start looking at our Multicast topology. You can see here we have all the devices in the demo, specifically our servers and receivers. Now, since we started the BSR topology, it should come pre-configured for Bootstrap Router, and so all we should need to do is get the traffic flowing. But before we do that, let's log into LHRB, which is our last hop router. Just go to the CLI and do a little bit of level setting. Let's look at the mroute table to see what multicast traffic we're already sending, receiving, requesting. Looks like here we have a star comma G or an any source PIM join for group 239.1.2.3. So let's jump into one of the receivers and see which one is configured to join this group. Okay, over on receiver 1, see if we can get into it. Yep. All right, let's take a look at the interfaces. Okay. And the next thing we need to do is look at the running config for the interface. And you can see here we're using IP IGMP join group 239.1.2.3. That's how we're signaling the upstream router to with that any source join to join that group. So the next thing to do is just to jump back over to LHRB, and then we'll take a look at the mroute table there, and you can see here we have our star comma G join for that group. Its incoming interface is gig03. Its outgoing interface is gig02. But who are these devices? Where are they? So let's look at CDP neighbors, figure out who they are. All right, as you can see, gig02 is the layer 2 access switch connected to the host, so that makes sense. And if we go look at interface gig03, you can see that it's marked to the incoming interface as MCAST A right here. Now, what is MCAST A and where is it on the diagram? I think we have to go back and reference that at this point. So you can see, again, that's our receiver. It's connected to a layer 2 access switch here, which is connected to LHRB on gig02, as we saw. So there's MCAST A connected to gig03. All right, well, that answers that question. Let's go back to PuTTY. And now a very important question to answer is, what is the rendezvous point that's configured in this network? Okay, let's see here. Okay, RP 3.3.3.3. Looks like it's for all groups. Notice that the info source is 4.4.4.4 and that it's coming in via bootstrap. So 3.3.3.3 is our RP, and our bootstrap router is 4.4.4.4. So you can see here, MCAST A is our rendezvous point. There it is. And MCAST B is actually serving the function of our bootstrap router for this network. I think the next thing that makes sense is for us to log into MCAST A, which is our rendezvous point, and confirm that our *G PIM join was received. So logging into MCAST A, let's look at the mroute table to see what's going on. Okay, great. So you can see that MCAST A did receive the *G PIM join. It is configured as the RP, so that is itself. And you can actually see that. And then for the incoming interface, it's null because we don't have any sources sending that to that group right now. And you can also see there's no reverse path forwarding check for that because it's not coming in. Our outgoing interface, however, is set to gig03, and it's set to forward. Of course, because this is the interface on which it received the PIM join. So who is gig03? Well, it's LHRB as expected. Let's take a look at where these PIM joins were coming from, all the way back to the source. So MCAST A received it on its gig03 interface, down to LHRB, which received it on its gig02 interface, and then the switch received it on its gig03 interface from the receiver. So that digs the canal all the way back. So the canal is dug all the way to the RP. Let's now log into the server and generate some multicast traffic. Okay, get in here now, and what we'll do to generate traffic is we're actually just going to send pings to the multicast group, which will just be forwarded to the first hop router as multicast traffic. And anyone who's listening will receive that multicast traffic and reply. So we'll repeat it, say, 10,000 times to keep the stream flowing, and let's just see the result. Okay, and it looks like we're already receiving replies. And who are we receiving replies from? Let's see here. Maybe the next one will show us. Oh, yep, there it is. 10.1.200.6 is replying to the traffic that we're sending to this multicast group. So let's see, who is 10.1.200.6? I think that's the next thing we need to figure out. Let's go back to our topology. 10.1.200.0. Okay, so it's one of the receivers, because that's their subnet. Let's jump over to receiver 1, since we already know it's got the IGMP join group on the interface, and yep, 10.1.200.6. So we know that this multicast river or tree is all the way built from the server to the receiver, and that the receiver is actually getting the traffic. So let's jump over to the RP and just take another look at the mroute table now that traffic is flowing. So here we go. Here's our S(G). This shows our source IP address, the server that's sending, and the group. And you can see that we have a couple flags set on this. The P is the prune bit, and the T is the shortest path bit. So this flow has actually already been cut over to the shortest path tree, you can see that the incoming interface is gig 01, which is towards the first hop router, but look, the outgoing interface list is set to null. So this has actually already been cut over in the time that we just started our ping to the shortest path tree. So let's check the best path from the receiver to the source now that we know who the source is. So just go ahead and start a trace route here. Let's see where we go. Okay. All right. I think that's done now. Looks like we go to first hop should be, I think that's LHRB. I believe that's MCAS B. And then the first hop router, and then the source. But let's go ahead and check the map and see here. Yep. Yeah. Yep, it goes from the switch to LHRB, then up to MCAS B, to the first hop router, and finally to the source. So that should be our shortest path, and we should find the multicast traffic flowing that way, since the unicast table best path is that way. Let's log into MCAS B, and we need to take a look at the mroute table and see what that looks like. Alright, you can see where our old star comma G is. You can also see that it's showing stopped because we have pruned the star comma G now that we've found the S comma G, which is the source group pair. Oh, had a little bit of a glitch there, but anyway, you can see the incoming interface is gig 01 and the RPF neighbor. And then of course on the outgoing interface, you can see that it's gig 02. So coming in from the first hop router, outgoing to LHRB. You can verify that on the map. That's what we expect to see. Cut over to the shortest path tree. And then we can look at LHRB and see, make sure the flow is happening the same way. So log into LHRB here, and we're going to show the mroute table there. Again, you can see we have our old star comma G. Right, and you can also see that it's stopped as expected. Down here you can see the S comma G, and there's a few flags to pay attention to. J for join the shortest path tree, and T for the SPT bet set. Incoming interface is gig 01, the RPF neighbor right here. And for the outgoing interface list of the oil, we're forwarding out gig 02. So let's see where those are. Go look at the map here. Okay, so for LHRB, yep, that's MCAS B, and we're forwarding out gig 02 towards that receiver, which is what we expect. For the last leg, let's just go take a look at the layer 2 access switch. Let's look at the IGMP snooping table. Okay. You can see we've turned it on for VLAN 200, which is our user VLAN. Okay, right there. See, snooping is enabled. Alright. Let's see, what's next? What should we do? We probably the next thing we need to do is to look at the groups. That's right, the groups is what we're looking for. So again, for VLAN 200 and for the multicast group, in it, and you can see the IGMP version join was a version 2 report, and that the receiver that sent the report is on gig 03 from the switch's point of view. So that should make sense. That's the receiver sending the IGMP report. And you can see here we have a querier set up on gig 01, 10.1.202. That's actually LHRA, which is kind of interesting. Didn't show B for some reason. Let's see here. Yeah, that's kind of a weird one. It should show that B is the querier, but here it's showing that A is the M router and the querier. So it's showing you that A is, for some reason, which A is not the multicast router, and we can actually verify that, but maybe I got some backwards. No? Yeah, gig01, LHRA. We can tell for 100% certainty that LHRA is not the M router because of the multicast flow we just looked at. So we can see that we're receiving multicast traffic from our S, G, and we're forwarding it. So for some reason, though, let's look at the PIM neighbor. Maybe that'll show what we're looking for. It does show us our neighbors for LHRB. Not showing me what I'm looking for, though. I'm looking for something very specific. Actually, let's jump over to LHRA and just do some level setting here. Just take a look at what LHRA sees. We'll look at its MROUT table. Well, yeah, just do that. Okay, so yeah, we're clearly not receiving any multicast flows here. You can see that we had a star comma G. We didn't send it, we never really sent it anywhere. We have no outgoing interface list. You can see the outgoing interface is null, so that's not it. Let's see if we show IP PIM interface. I think it's interface that I'm looking for. Yeah, this might be it. Do I need detail? Yeah. Okay. Let's just do it. Okay. Yeah. This is what I'm looking for right here. So you can see all of the PIM settings for this interface. Specifically, you can see the PIM DR, or designated router for the segment, is 10.1.200.3, which is LHRB. So the designated router, or the M router for the segment, is B. So I'm not sure why the access switch said it was A. Just maybe I'm not sure if that's a bug or just what's going on there, but let's just, check the same on LHRB just to make sure it's right. Yep, see, PIMDR, this system. So LHRB clearly is the designated router or the multicast router for this segment. So go back to the map. Yep. Okay, so this was basically just showing this specific topology. We'll just go ahead and disconnect everything before we start a new topology so that, when it spins up the new topology, it doesn't mess up the PuTTY at all, which it shouldn't mess it up, but this way we just start clean. And I'll go ahead and start the Sandbox topology. Again, we started with the BSR, the bootstrap router topology. So I'll just start the Sandbox topology here. And we'll spin it up because this is going to take a few minutes to complete. Okay, that should just about load it. Yep. So when the automation is complete, it always loads the diagram, and the diagram doesn't change between the different topology solutions, just the settings, the multicast configuration. So since we picked a Sandbox topology, well, basically nothing should be happening. Nothing's pre-configured, rather, except for the IP addressing, the routing protocols. I think we're using EIGRP in this case. All the PIM adjacencies are configured on the interfaces. As you can see here, we've logged into this router and it's still booting. You can see PIM coming up. We can see EIGRP coming up. So from a solutions perspective, the Sandbox topology has nothing but the basic network configuration. So if we look for an RP, there isn't one configured, and we'll see that here in a second. And then, there's no multicast configuration at all beyond, again, just the basic PIM adjacencies. So This is for you to configure however you like, see it going. That's it. I'd like to thank everybody for viewing, and I hope everybody finds this informative. And my hope is to be able to release this near Barcelona so that other people can practice multicast in a safe environment, and use it to tie it back to my multicast breakout. Thanks.